Rubber insulating gloves are essential for electrical work, protecting against electric shock. You can find them at various retailers. Home improvement stores like the Home Depot, Lowe's, Ace Hardware, and True Value are good starting points. Online retailers such as Amazon, Grainger, Wesco, and McMaster-Carr also offer a wide selection. Electrical supply stores like Ferguson, Rexel, and electrical wholesalers specialize in these types of products. The price range for a good pair of Class 0 or Class 1 rubber insulating gloves typically falls between $20 and $80. Higher-end gloves, such as those for Class 2 or Class 3 insulation, will be more expensive. Several factors are important when choosing a good pair of rubber insulating gloves. Firstly, check the ratings. Look for gloves rated for Class 0, Class 1, Class 2, or Class 3 insulation, depending on the level of protection you need. The class indicates the maximum voltage the gloves can withstand. Secondly, consider the material. Natural rubber gloves offer the best electrical resistance. Synthetic rubber gloves, such as nitrile or neoprene, are more durable and resistant to chemicals. Your work environment might dictate which material is more suitable. Thirdly, ensure proper fit. The glove should fit snugly without being too tight or too loose. A good fit allows for dexterity and prevents discomfort. Remember to inspect the gloves regularly for any cuts, tears, or damage. Replace them immediately if any damage is found. Proper care and maintenance will extend the life of your gloves. The voltage ratings for the different classes of gloves are as follows. Class 0 gloves provide protection up to 1000 volts alternating current. These are often used for general electrical work where the risk of contact with higher voltages is low. Class 1 gloves offer protection up to 7500 volts alternating current. They are suitable for higher voltage applications in residential and commercial settings. Class 2 gloves are rated for up to 17,000 volts alternating current and are used in more demanding industrial environments. Class 3 gloves provide protection up to 26,500 volts alternating current, and Class 4 gloves protect up to 36,000 volts alternating current. These higher classes are typically used by utility workers and those working with high voltage equipment. The material of the gloves also plays a significant role in their performance. Natural rubber gloves, made from latex, offer excellent flexibility and sensitivity, allowing for better grip and dexterity. However, they are more susceptible to damage from oils, chemicals, and extreme temperatures. Synthetic rubber gloves, such as those made from neoprene or nitrile, offer better resistance to chemicals, oils, and abrasion. They are also less prone to degradation from ultraviolet light and ozone. However, they may not provide the same level of flexibility and sensitivity as natural rubber gloves. When selecting rubber insulating gloves, it is essential to consider the specific hazards you may encounter in your work environment. If you are working with chemicals or oils, synthetic rubber gloves may be the better choice. If you need maximum flexibility and sensitivity, natural rubber gloves may be more appropriate. In addition to the voltage rating and material, other factors to consider include the length of the gloves, the cuff style, and the color. Longer gloves provide more protection for the arms, while different cuff styles may be more comfortable or provide better protection against liquids or debris. The color of the gloves can also be important, as some colors are easier to see in low light conditions or against different backgrounds. Remember that rubber insulating gloves are only one part of a complete electrical safety program. It is also important to follow safe work practices, use other personal protective equipment, and receive proper training on electrical safety. Regularly inspect your gloves before each use, looking for any signs of damage, such as cuts, tears, punctures, or chemical contamination. If you find any damage, discard the gloves immediately and replace them with a new pair. Store your gloves properly when not in use, away from direct sunlight, extreme temperatures, and chemicals. You can also use a glove bag or container to protect them from damage. Clean your gloves regularly with mild soap and water to remove dirt and grime. Avoid using harsh chemicals or solvents, as these can damage the rubber. Dry your gloves thoroughly before storing them. Consider using glove liners to absorb sweat and moisture, which can help keep your gloves clean and comfortable. Glove liners can also provide an extra layer of insulation and protection. Make sure the glove liners are compatible with your rubber insulating gloves and do not interfere with their performance. When putting on your gloves, avoid stretching or pulling them excessively, as this can weaken the rubber and increase the risk of damage. Roll the gloves on carefully, making sure they fit snugly and comfortably. Perform an air test on your gloves before each use to check for leaks. To do this, trap air inside the glove by rolling the cuff tightly, and then listen for any hissing sounds. If you hear any hissing, the glove is leaking and should not be used. Also, visually inspect the inflated glove for any signs of damage. Follow the manufacturer's instructions for proper use, care, and maintenance of your rubber insulating gloves. Different gloves may have different requirements, so it is important to read and understand the instructions before using them. Ensure you are properly trained on how to use and care for your rubber insulating gloves. Training should cover topics such as glove selection, inspection, testing, storage, and maintenance. In addition to rubber insulating gloves, you may also need to use other types of gloves for electrical work, such as leather protector gloves. Leather protector gloves are worn over rubber insulating gloves to protect them from abrasion, punctures, and other damage. They also provide additional grip and comfort. Make sure the leather protector gloves are compatible with your rubber insulating gloves and do not interfere with their performance. Inspect your leather protector gloves regularly for any signs of damage, such as cuts, tears, or holes. Replace them immediately if any damage is found. When working with energized electrical equipment, it is crucial to use the correct type of gloves and other personal protective equipment. Using the wrong equipment or failing to use it properly can result in serious injury or death. Always follow safe work practices and procedures when working with electricity. To energize equipment whenever possible before working on it. If you must work on energized equipment, use appropriate personal protective equipment, including rubber insulating gloves, safety glasses, and insulated tools. Maintain a safe working distance from energized equipment. Use barriers and other safety devices to prevent accidental contact with energized parts. Be aware of the potential hazards in your work environment, such as overhead power lines, underground cables, and confined spaces. Take steps to mitigate these hazards before starting work. If you are unsure about any aspect of electrical safety, consult with a qualified electrician or safety professional. Continuous learning and training are essential for staying safe when working with electricity. Keep up to date with the latest safety standards, regulations, and best practices. Attend safety training courses and seminars regularly. Share your knowledge and experience with others to promote a culture of safety in your workplace. Always prioritize safety when working with electricity. Your life and the lives of others may depend on it. Working on electrical equipment can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock and other hazards. By following these tips, you can help ensure your safety when working with electricity. Remember to choose the right gloves for the job, inspect them regularly, and follow safe work practices. Rubber insulating gloves are an essential part of any electrician's safety gear. They provide protection against electrical shock, which can be fatal. The gloves are made of a special rubber compound that is designed to resist the flow of electricity. The gloves are tested to ensure that they meet the required safety standards. The testing process involves subjecting the gloves to high voltages to see if they can withstand the voltage without breaking down. The gloves are also inspected for any defects, such as cuts, tears, or punctures. If the gloves pass the testing process, they are certified to be safe for use. The certification process is typically done by a third-party testing laboratory. The gloves are marked with the voltage rating and the class of protection. The voltage rating indicates the maximum voltage that the gloves can withstand. The class of protection indicates the level of protection that the gloves provide. It is important to choose the right class of gloves for the job. Using the wrong class of gloves can put you at risk of electrical shock. The gloves should be inspected before each use. Look for any signs of damage, such as cuts, tears, or punctures. If you find any damage, do not use the gloves. Replace them with a new pair. The gloves should be stored in a cool, dry place. Do not store them in direct sunlight or near heat sources. The gloves should be cleaned regularly with mild soap and water. Do not use harsh chemicals or solvents to clean them. The gloves should be dried thoroughly before storing them. The gloves should be tested periodically to ensure that they are still safe for use. The testing should be done by a qualified testing laboratory. The testing interval depends on the frequency of use and the environmental conditions. The gloves should be replaced when they reach the end of their service life. The service life depends on the type of gloves and the environmental conditions. Follow the manufacturer's instructions for proper use, care, and maintenance of your rubber insulating gloves. The Occupational Safety and Health Administration, or OSHA, has specific regulations regarding the use of rubber insulating gloves. These regulations are designed to protect workers from electrical hazards. It is important to be familiar with these regulations and to follow them carefully. OSHA requires that all employees who work with electricity be trained in electrical safety. The training should cover topics such as the hazards of electricity, safe work practices, and the proper use of personal protective equipment. OSHA also requires that employers provide their employees with the necessary personal protective equipment, including rubber insulating gloves. The gloves must meet the requirements of the American National Standards Institute, or ANSI. OSHA requires that employers inspect their employees' rubber insulating gloves before each use. The gloves must be inspected for any signs of damage, such as cuts, tears, or punctures. If any damage is found, the gloves must be replaced immediately. OSHA requires that employers store their employees' rubber insulating gloves in a clean, dry place. The gloves must be protected from damage and contamination. OSHA requires that employers test their employees' rubber insulating gloves periodically. The testing must be done by a qualified testing laboratory. The testing interval depends on the frequency of use and the environmental conditions. OSHA requires that employers replace their employees' rubber insulating gloves when they reach the end of their service life. The service life depends on the type of gloves and the environmental conditions. It's crucial to check the manufacturing date on new gloves before use. Rubber degrades over time, even when unused, so gloves past their expiration date should not be used for electrical work. Regular inspection includes not only visual checks for punctures and tears but also an inflation test, as mentioned earlier, to detect any subtle leaks that may not be visible. The fit is important not only for comfort and dexterity, but also for safety. Gloves that are too tight can restrict movement and increase fatigue, while gloves that are too loose can slip off or allow contaminants to enter. Consider the climate in Florida. High humidity and temperatures can affect the comfort and performance of rubber insulating gloves. Glove liners can help absorb sweat and moisture, keeping your hands dry and comfortable. The proper selection, use, and maintenance of rubber insulating gloves are essential for protecting yourself from electrical hazards.